We want to differentiate the following with respect to x. We have y cubed plus y squared minus 5y minus x squared is equal to negative 4. We're taking with respect to x, which means every other variable will have to have a d that variable dx with it, okay? We're going to just use y prime to notate that because we only have one of those. We only have one other variable. So, if I take the derivative of y cubed, what do I get?
3y squared
Multiplied by,
Y prime.
okay? Or dy dx plus 2y y prime or dy dx minus 5 times y prime or dy dx minus 2x. The derivative of negative x squared is minus 2x, so we don't need any differentials with that because that's really a dx. And that equals, what's the derivative of negative 4? 0. And it doesn't need anything because it's 0. It doesn't matter, what variable it is because it didn't vary. So here's what we get for our derivative. And then before we can call ourselves finished, we need to figure out a way to isolate a single y prime. So here's a trick that will work every time. First, rearrange it so that on one side you have every term that has y prime in it. And everything that doesn't, you put on the other side. So I want to keep the first 3 terms on the left, and I'm going to move this minus 2x to the other side. So the first thing you have to do is you have to rearrange it to get all of your dy dx's or y primes by themselves. So we have 3y squared y prime plus 2y y prime minus 5y prime, and we're going to move the negative 2x to the other side because it doesn't contain the variable I am solving for. That's how you solve for a specified variable. I'm trying to solve for y prime or dy dx. So I move everybody that isn't attached to one of those to the other side. Now all you do is factor a single y prime out. It doesn't matter if you can take anything else out. You don't take out the greatest common factor. You only take out the y prime. Leave everybody else in there. So we'll take out a y prime or a dy dx, and we will have 3y squared plus 2y minus 5. And that has to equal positive 2x. And then for your final step, you divide everybody through by the parentheses and leave y prime by itself on the left. So we will divide by 3y squared plus 2y minus 5. And the parentheses technically aren't necessary. I just put them there to show that this is going to reduce to 1, or simplify to 1, and we are left with y prime or dy dx equals 2x all over 3y squared plus 2y minus 5. So it gets a little more complicated when you have multiple terms that contain the variable, the dependent variable there, or the y's, but it's still relatively simple algebraically if you just get in the habit of following those steps. So for our final answer, we get 2x over 3y squared plus 2y minus 5, or you could factor that denominator into 3y plus 5 multiplied by y minus 1. Unless the directions say you have to factor, however, you don't have to factor your final answers. I will caution you, though, to be on the lookout. If something will factor from the top and bottom and reduce, you do want to simplify your derivatives. But we had no reason to believe, even if this did factor, nothing was going to simplify. So really putting it in factored form didn't get us anywhere. But just pay attention to directions if you're unsure. For the next example, we want to find dy dx for the function x squared plus y squared equals 1. Does this function look familiar to you? It should. We spent a whole semester studying it last year. It's not only a circle, it's a circle centered at 0, 0 with a radius of 1. He has a special name. What's he called?
Unit
circle. It's our unit circle. So we're going to find the derivative with respect to x of our unit circle. So if I take the derivative of x squared, I get
2x.
And the derivative of y squared, I get
2y.
2y prime, because we have to put a dy dx there, equals 0. The derivative of a constant is always 0. So now we have 2x plus 2y prime equals 0, and we need to isolate our y prime terms on one side and our non-y primes on the other. So I'm going to move the 2x to the other side. I have 2y prime equals negative 2x. And because it's a single term, I don't have to factor. I can just divide everybody through by,
Negative 2y.
how about positive 2y? Is that okay? Positive 2y. And that gives us that y prime, or if you want to follow the notation in the problem, we should do dy dx. I'm not really picky about you switching notation there. Equals a negative divided by a positive is a negative x over y. So it turns out that I can find the slope of my unit circle by taking any point on it and stacking the opposite of x divided by the y, and that would find the rate of change of whatever was happening on that unit circle. Now I want to find the slope of the graph of 5y cubed plus 3x squared equals 37x at the point where x equals positive 1. So what's the derivative of 5y cubed? 15y squared times dy dx, or times y prime, plus 6x, and that one doesn't need a dy dx because it was a dx equals what? 37. So my calculus is basically done. Now it's just going to be algebraically isolating that y prime. So if I get y prime by itself, I need to move the 6x to the other side, and I have the term 15y squared y prime is equal to 37 minus 6x. And from there, to isolate the y prime, I just divide both sides by 15y squared, right?
Yes.
So my derivative, we call that an implicit derivative because it involves both x's and y's. 37 minus 6x all over 15y squared. So if I asked you just to find the derivative with respect to x, you would be finished. But I asked you to find the slope at the point where x was 1. In order to do that, I need to turn that into a number. And we do that by plugging in values for our variables. So I know I'm going to plug in a 1 for the x. So 37 minus 6 times 1 all over 15y squared. But it didn't give me a y value. I have to find a y value to go with that x. To find a y value to go with that x, you simply plug the x into the original, and that will give you a y value if it didn't give you 1. So we're going to come off to the side over here, and we're going to take the 1, we're going to plug it into the original. We have 5y cubed plus 3 times 1 squared equals 37 times 1. And that will give us 5y cubed plus 3 equals 37. Ooh, this is not going to be pretty. So that gives us 5y cubed equals what? 34. So that means that y cubed, oh goodness, is 34 over 5. And I have to isolate that by taking the cube root. I didn't think this one through. Y equals the cube root of 34 over 5. And I need to substitute that.
Is it plus or minus?
No, not when you take the cube root.
Okay.
The cube root will maintain its sign. You don't have to worry about the positive and negative. All right, that is what I need to substitute into my derivative in the place of y. So I have the cube root of 34 over 5. This is not going to be pretty. We can do it. Okay. So let's go ahead and clean the top up. The top becomes what? 31. And the bottom becomes 15 times the cube root of all of that squared. Now if I want a decimal, you can handle that, no problem, no questions asked. You could just type that into your calculator using alpha y equals. My concern is you may end up in a Cal 1 class where you're not allowed to use graphing calculators, or sometimes any calculators. So we need to algebraically talk through that. All right, if I square these, basically I have no idea. Okay, let's try it. I get the cube root of 34 squared. What's 34 squared?
No idea.
Try again.
1156.
Okay, I get the cube root of 34 squared is 1156 all over the cube root of 5 squared, which is 25. Are we good with that? Okay. Do y'all notice that I am dividing by a fraction? So here's what I see. I see that we have 31 over 15, and on bottom, I have a fraction. Well, do y'all understand I could just flip that and change it to multiplication? Right now the 31 is being divided by this fraction. Do you guys understand that? Could I flip it and say that it's times the cube root of 25 over the cube root of 1156?
Yeah, I guess so.
That's, guys, if you divide something by a fraction, isn't the same as multiplying by the reciprocal?
Oh.
Right? Okay. So that's what happens there. So basically, if I wanted you algebraically to just do as much as you could without a major calculator there, or I wanted you to leave it in exact form, this is what I would be looking for. 31 cube roots of 25 over 15 cube roots of 1156. Now, I'm of the opinion that that tells me very little, okay? So that doesn't matter to me. I will usually, if things are that ugly, ask you to round it. So give it to me as a decimal. Let's round it to 3 decimal places and see what we get. So we'll pause and we'll take our calculator out and we'll do some computation. So we typed it in and we got approximately 0.576. So our slope at that moment in time is approximately 0.576 y units over x units.